Hi everyone, welcome to InfosecTrain. This is Ashidhani, and today we are here for the webinar of Mastering the Art of Web Application Penetration Testing, Day 2. Yesterday, we discussed about some of the basics, what is HTTP, what is HTTPS, and what are the different things in HTTP. Some of the basics we discussed. Now, the next thing we are going to discuss about is authentication. That what is authentication, how authentication happens in HTTP, right? Then we'll talk about OWASP top 10, that what OWASP top 10 is and what exactly it gives you. And then we'll talk about how to exploit the authentication based vulnerabilities. We'll understand the access controls, and I'll show you how to exploit access control based vulnerabilities, right? So this is the agenda for today. I hope you guys are excited. Okay, so let's start with our masterclass. So the very first thing is authentication. Now, when we are talking about authentication, it means that we are basically identifying the user if the user is same whom he or she is claiming to be, right? If I'm claiming to be Ashish, right? So there should be some way by which you can authenticate if I'm the one whom I'm claiming to be or not, right? Many times we visit ATMs, right? So when you go to ATM, in ATM, you put your card, your debit card, and then you enter your PIN, right? Then you are authenticated. You are allowed to access the account you are trying to access, and then you are able to withdraw the money. Yes. So in technical terms, I'll say that authentication is the process of verifying a user or device before allowing them the access, right? Now, when we talk about authentication, it is a three-step process, right? Whenever you want to gain access to any digital resource, there is a three-step process. First thing, I will be identifying, right? So identification, then authentication, and then authorization, right? Identification means who are you? So it needs a user ID like username you enter, right? So that username is identification. Without identity authentication, there is no way to know if that username actually belongs to the person who is entering the username or not, right? That's where your authentication comes in. When you are pairing the username with a password or any other verifying credentials, then identification and authentication both are happening, right? And the most common way of authentication is login and using username and password, right? And then comes authorization. This means in layman terms, do you have permission? The resource you are trying to access, if you are having the permission to access that resource or not, right? That is authorization. These are the three steps which we have in authentication, right? Now we know that there is authentication, and we know that we have heard many times two-factor authentication or multi-factor authentication. What does this word factor means in this? So authentication depends on some factors, right? Now those factors are what? There are three main factors. First one, something you have. Second is something you know. And the next one, third one is someone you are. Something you have, that means something you are carrying, right? So it's a possession kind of factor. You are carrying your access card, your RFID token, which you will punch down in your organization, and you will get the access inside the gate of organization, right? That is something you have, right? You are carrying something, right? Something you know, password, right? Only you remember it. You're not holding it, but that password of or any pen, you know, right? That is something you know, and someone you are, IDs or something else. Identification. Identification using biometric. Correct. Right? So it is your fingerprint scanners are there, your retina scanners are there, even iris scanners are there. So all these scanners they come under someone you are, right? That's your identity, physical identity by which I can identify you. Every person's fingerprint is different, right? Every person's iris is different. Every person's retina is different, right? So that is someone you are. So when you are using more than two factors or two factors of authentication, these are the factors which are used. So if you are using something you have, that means any card, let's say your debit card, right? And if you are also carrying, you have a pin, right? You enter the pin for your debit card as well. So this is two-factor authentication, right? If you are using all the three factors, like you have a card, you have set a pin on that as well, and you are like using your fingerprint also. Three factors you are using, so we call it multi-factor authentication, right? Now, latest case of authentication bypass, Uber was hacked. So in Uber, what happened? Somehow the attacker was an 18-year-old boy, and what he did, he basically found the credentials from the VPN shared folder. He got inside the network of Uber, and in the VPN's shared folder, he got found the credentials of one of the user. Then there was two-factor authentication being used, right? First thing, you have to enter your username and password, and then there will be a push notification in your mobile phone. You might have seen that push notification when you authenticate yourself in a new device, when you authenticate your Gmail account or Google account in a new device. So there will be a push notification that click on this number or click on yes on other phone, right? So there will be a push notification. What attacker used social engineering to bypass it. Attacker called that person, asked him that I'm talking from the IT team of Uber and we are testing a new feature. Now we have your username and password, but for accessing your account, there will be a push notification in your mobile phone. Do one thing, I'll send a request and you just press yes. That person believed and clicked yes on his mobile phone. When he clicked yes, attacker was fully inside the network of Uber. That's how it was bypassed. So it's not always 100% technical to bypass the things. The ways of bypassing means that you are contradicting some statement or contradicting some rules, right? So you might have heard, like in this fancy world of hacking, we have heard that we are bypassing the firewalls, we are bypassing EDRs, MDRs, XDRs, right? IDS, IPS, multiple things, right? Whatever security measures a company takes, we are bypassing them. We have always heard that it's bypassing means compromising or unauthorized access, but it's not that. It's just contradicting, right? Contradicting some rules. So you are a person who is working in a firewall and you have written some rules for the network and firewall. I found that what rule is missing? That's a contradiction which you have not written, and I used or I sent a packet whose rule is not written in the firewall and it is bypassed. Bypassing means something up you found that your firewall or your security measures they allow, right? That's the thing. So it's not always 100% technical to bypass the thing. Sometimes you just have to have a good way of speaking, how you speak, right? How you perform social engineering so that you can break into the mind of a person and manipulate. Yes, we can do that. That's also bypassing, like the attacker did. Now, next thing, we are talking about web applications. Now, here also authentication is same, right? The meaning of authentication will stay same. It's a way of identifying yourself to the web server. You need to show the proof that you have the rights to access the requested resource. And for that, you will give a combination of username and password, which the server will validate and then decide if you can access the resource or not on the basis of the permissions and the privileges you have. Right. Now, there are two types of authentication in HTTP, right? The very first one is basic authentication, and second one is digest authentication, right? Now, when we are talking about basic authentication, before going to that, I'll just tell you that there are some things that we need to understand, right? First thing that you should understand is HTTP, it uses a framework which is called challenge and response framework, right? Now, when we are talking about challenge and response authentication framework, what does that mean? It means when you are sending a request, instead of responding to it immediately, your server will send an authentication challenge. It will challenge the user to provide the proof of identity by entering a secret information. After that, the request will be again repeated, right? First, you are trying to access a web server. So you sent a request to the web server. Web server replied back with a challenge, right? Authentication challenge. You will give your username and password. With username and password, again the same request will be traveling. And if the credentials you have provided they are correct, the user will get the expected response. And in case the credentials are wrong, the server can reissue the challenge or just send an error message, right? This is the first thing that you should know, right? Second thing, if you remember yesterday, we discussed about headers, the request and response headers, right? Now, what these request and response headers are, whenever we are talking in terms of authentication in the web application, so what we learned that server will give a challenge to you. So how the challenge will be shared? There is a header www-authenticate. www-authenticate is a response header which is sent by whom? The server. So it contains the information about first thing authentication protocol, right? Which authentication protocol will be used and security real, right? See, the thing is, uh, security realm give you a way to associate different access rights to different resource group on the server, and those are called protection spaces. Security realms, they provide a way to associate different rights to different resource groups on the server, and those are called protection spaces. Security realms, they provide a way to associate different access rights to different resource groups on the server, and those are called protection spaces. Okay, so what this means, it is that depending on the resource you want to access, you might need to enter different credentials. On a web application, whatever resource you want to access, for every resource, there can be a different credential set, right? You are a user of website InfosecTrain, though you don't have to create yourself an account on InfosecTrain, but let's assume that you have to create an account on InfosecTrain. So at that time, if you are logging in, so you have to enter different credentials. But if I have to log in, I will be admin, I have to enter different credentials. So you are a guest user, you are accessing guest place, and I'm admin user, I'm accessing admin place. So this is security real different for both of us. A server can have multiple realms, right? For example, let's say there is a one security realm which I have created for website statistics information, which can be only accessed by me being an admin. Another realm I have created for website images, which other users can access and upload images to, right? You are able to view the images, but you are not able to see the statistics. Yes. So security realm is what? How you will see it? It will be written, let's say slash admin. I am inside admin directory. Inside admin directory, statistics, and inside statistics, let's say financials dot txt, right? So this is the file that I'm trying to access. Now after this, it will be written the realm. Realm is admin stats. So now realm is doing what? It is telling the authorization. Yes. What if the realm equals to admin stats? That means a normal user cannot access this place, this resource, even if you are giving correct credentials, your correct credentials, right? You are allowed to access the images. So you will go to the images directory of the server and let's say image1.jpg, right? And the realm is written as, let's say, images, right? So you are allowed to access images. So www-authenticate header will have the information about what authentication protocol you are using and the security realm. Security realm is defined when the developer is writing code. So you have to define the different places or different pages a normal user can access and what admin can access, right? Perfect. Now, what happens? Your www-authenticate gives you the authentication protocol. It's defined in the code which developer has written, and when your request is going, when you are sending the request, right? So what happens? Let's say what happens whenever you are sending a request to the server, right? So server will reply back to you. How it will reply back? HTTP, let's say 1.0 I'm using, and then it will send 401. 401 means unauthorized, right? And www-authenticate header will have basic authentication I'm using, and realm I'm trying to access is admin stats. This will be the reply from the server. Now after this, you will reply back, you will give your credentials, and you will be authenticated, and your privileges will be given to you according to the account you are using. When we are talking about authentication, so as I said, there are two types of authentication: basic and digest. Now basic authentication means you are using old mechanism, right? Username and password in encoded format, you are traveling and done, right? So what happens, let's say the same example I'm taking, right? Same request, right? Let's remove this, let's add something else. Now the very first thing, user agent or your browser, you are sending a request to the server. Now what request you are sending? A get request. Let's say I want to access gallery, right? And inside gallery there is a directory with the name personal, and inside personal there is images, and then img1.jpg I'm trying to access, right? And http version 1.1, right? And host is, let's say, www.infosectrain.com. This is what you are sending, this is your get request. So after this, what will happen, the server will reply back to your user agent, right? That access is denied, http 1.1, access denied, right? And 401 will be the status code, right? Then it will tell www-authenticate is there, right? What type of authentication method we are using? Basic, and the realm is gallery. You're trying to access gallery. Yes. Now user will get this information. Now user will get to know that yes, I have to send my username and password to the server. So user will say again the same request, and then user will send another header, authorization basic, and let's say ZM9VOMJHCG equals to, right? Yes. So what user is sending? User is telling that I am using basic authentication, and in basic authentication, this is my username and password, right? Now this username and password is encoded. What kind of encoding it is? So whenever you see equals to or double equals to sign at the end of any encoding, that is base 64 encoding. Now, in this whole communication between the browser and the server, what we found that basic authentication will pack the username and password into one string, then separate them using colon. So if you will basically decode this, right, it will be just this username and password. Foo is the username, bar is the password. Yes. So attacker can easily get the password. And even worse than that, encoding the username and password will not help. An attacker could still send the scrambled sequence to achieve the same effect, right? There is no protection against the proxies or any type of attack which will change the request body and will leave the request headers intact, right? So basic authentication we can say is less than a perfect mechanism, right? It can be used to prevent accidental access to protected resources, and it gives a degree of personalization, but it's not 100% secure, right? Then the second type of authentication that we discussed was digest authentication. Now, digest authentication is a bit different. We use hashing there, we use multiple things, right? So, what happens? Let's say we are sending a request, right? User is sending request to the server. Okay, let me zoom in. Yeah, no, it's fine. Now, this is the request that user is sending. That get slash dir index dot html and http 1.1.0 we are using. Host is localhost, right? Now the server will reply back to the user. First thing, we know that it will be 401 unauthorized, right? That you are not authorized. You have not given your username and password, correct? Can you see this reply? Or shall I zoom in more? So www-authenticate authentication mechanism used is digest. Then it is giving the realm, which realm I'm trying to access. Then there are some other things, QOP, nonce, opaque, and then the error data and the information about the HTML page, right? So the server will challenge the client to authenticate using digest authentication, and whatever information the client will need for replying back, all that information is there, right? So we'll talk about this QOP and nonce. What are these things? Because I know you guys have that question in your mind, that what is this QOP? What is this nonce? What is opaque? What are these things? We'll talk about them as well, right? Now, once user gets the reply from the server, user will have to give the username and password now, right? Now, how the user will give username and password? It's very interesting, and it's this, right? So user replied back to the server authorization, that authentication mechanism being used is digest, username is Gandalf, and then realm is this, nonce URI, the place I want to access, QOP, NC, CNonce, response, opaque, right? Lots of the things. Yes. Now, what happens? First thing, we talk about nonce and QOP, nonce and opaque. This nonce which we are talking about, this nonce is set by the server. The server defined these strings, and that should be returned by the client as they were received. So these two things will be included in the reply which is sent by the user to the server, and both of these values will be same, right? That's nonce and opaque, right? Then comes QOP. QOP stands for quality of protection, right? So quality of protection means one, or it has one or more predefined values. How you will compute the digest? That means how you will compute the last outcome, how you will send the password of your account, right? So it can be authentication int, that means integer based authentication, and it can be token as well. The true token will do the authentication. That's quality of protection, right? Next thing, when we talk about let's say CNonce. CNONs, it stands for client nonce, right? So if you are using quality of protection, then CNONs will also be used. So it is used to avoid plain text attack, and it provides message integrity protection, right? CNONs is the value that you give to a, let's say, your password, right? Or whatever data you are sending. So the value of CNONs will change if the value of your password will change, because we are using hashing here. I'll show you how we are using hashing here. See, hashing is an algorithm which is performed on the data, right? And it gives you an output which is called hash, right? You are performing an algorithm. Now, hash or hashing is one-way process, or you can say one-way street, right? It is used to maintain the integrity of the data. Now, if I'm saying my password is Ashish123, right? And I calculated hash of it. Let's say hash became 0, 0, A4BF11349C, right? This is the hash value that I got. If any attacker makes changes to it, makes changes to my password, or makes changes to any data which I am sending, even a slight change will change the value of my hash. If I write it like this, Ashish123, right? In all in lowercase. A was in uppercase before, but now in lowercase. So the value of hash won't be the same. It will be different, right? So same like that, CNONs is used to avoid plain text attacks, right? And then NC. NC stands for nonce count. Nonce count means it is a number which is given to every single request, right? Once it is set, it will be value will be given to every single reply, because what happens, there are replay attacks, right? Now, what are replay attacks? Attackers, they will send the same request multiple times. So if the same NC value is seen twice, then the request is a replay and the request will be rejected, right? So just understand it in a way that I'm sending a request to you. Every request has a sequence number 0001, right? Then 0002. In between, there is an attacker setting. Now, what attacker did? Attacker sent the same request 0002 to me again from your device. So I will understand that this is a replay attack, and I will deny to accept that request, right? So that's how you communicate and authenticate. Now the thing is, once the user has sent all these details, right? How all these details came into the picture, right? Because there is something which you didn't ask with the name response. Maybe this response is the password. It can be, right? In this response, there can be the password of the user traveling and you are not aware about it. So how will I get to know that where the password is, right? So first thing, you should know that here the hashing which is used is MD5 hash, which is least safe. But MD5 hash, how it's generated. Let's say I have some data, right? Now that data I have converted into form of bits. That's what I'm telling how the MD5 hashing works, right? Let me type that. Now what happens? I have converted my file into bits, right? Now, once they are converted into the bits, what will happen? XOR operation will be performed, right? Now, those who are not aware about the XOR operation, that what happens in XOR, if in a column number of ones are even, the output is 1. Otherwise, 0, right? So whenever XOR operation is done, we have to check if the number of ones are even in a column or odd, right? So if you see in the first column, if we calculate, all three are 0, so output will be 0. Then output will be 1, 0, 0, 0, 1, 0, 1. So after calculating, I got this output. This is message digest hash. So message digest means it is irreversible. Why it is irreversible? Hashing is irreversible because if I'm saying that there is a number, let's say 79, what numbers I have added to make 79. So you will give me multiple ways. You can say that 78 plus 1, you can say 75 plus 4, you can say 70 plus 9, you can say you added 179 times. There will be multiple combinations which you can make, right? But you will not be able to tell exactly what I did, right? So same like this, if I give you 010 110 and 0, this output, and I want to find out what binary values were there. Can you find that out? No, you cannot, right? So that is called message digest. So here message digest is being used. Now where it is being used, all the attributes are first calculated, all the things that you have used in your response, right? All of them are calculated. So if you see here, the username is here, the realm is written, and the password Lord of the Rings, right? So all these three things went through MD5 hashing, and this is the output of the hash, right? Then the get request and the directory you're trying to access, that also they took through MD5 hash, and they got one output. In response, what you have, response is calculated with the help of this, the hash which we found after after combining the username, realm, and password, right? Then there is the directory you're trying to access, that is also being sent, right? And what else? The value of nonce. Can you see? CMFUZG9. The value of nonce is also there. The value of C nonce is also there. The value of NC nonce count is also there. And what kind of authentication you are using, that is also there. So all these things are combined, and again MD5 hashing is done over them. Then you came up with something which is called response. And that's how in your above request, your response is added. So this is HTTP authentication, basic and digest, right? Next thing, which we have to talk about is OWASP top 10. So OWASP, it stands for Open Web Application Security Projects. right? Open Web Application Security Project. Now, what that is? OWASP is an organization which gives you uh, top 10 vulnerabilities or top 10 attacks, right? Now, the thing is that OWASP started in 2003 only for web applications. Nowadays, there is OWASP top 10 for web app, right? You will find OWASP top 10 for IoT, for OT, for mobile, right? For cloud, right? For everything there is a OWASP top 10, right? For LLMs there is an OWASP top 10. There is for APIs there is an OWASP top 10, right? For everything there is a risk or the attacks provided by OWASP, right? But when it started in 2003, how they started, the people who are working, first thing, OWASP is a uh, non-profitable organization, right? So they are not like earning organization. Now, when we talk about OWASP, it started in 2003, and what they exactly did, they made one application, right? Developed one application, made it out public. Once the application was public, people from all over the world, they started attacking the application. When they started attacking the application, so everyone used different methodologies, different attacks, different vulnerabilities, everyone targeted. So they found vulnerabilities and exploited those vulnerabilities. People in OWASP, they started categorizing those attacks, right? So once they started categorizing those attacks, what happened exactly? They came up with a list of top 10, right? Top 10 vulnerabilities which were exploited. And from that year, every 3 years or 4 years, OWASP releases a list of top 10 vulnerabilities so that you can safeguard your organization. A very big mistake which people do while they are understanding OWASP top 10 is that they understand and they think that there are only 10 vulnerabilities in OWASP. What OWASP has done very thoughtfully and I think intentionally, they have created categories of attacks. These are not vulnerabilities only, these are categories of vulnerabilities, right? There are vulnerabilities also, but there are some categories also. Let's say there is injection written, right? Injection is not only a one vulnerability, it is a category of vulnerabilities, right? So if you talk about code injection, right? OS command injection, right? If you talk about LDAP injection, you talk about SQL injection, right? You talk about XXE, cross-site like external XML entities, right? You talk about cross-site scripting. All these are the types of injection that you are doing. So they all are part of injection. So when you learn injection, you not only learn SQL injection, but you learn different types of injections. What are the different ways and what things we can inject inside, right? And that's how you should understand OWASP top 10 always. Now, let's talk about this OWASP top 10 one by one. The first one is broken access control, right? Now, when we talk about broken access control, there were two vulnerabilities in OWASP Top 10 2017. One was with the name IDOR and second was with the name missing functional level access control, right? IDOR stands for insecure direct object reference. Both of these vulnerabilities were combined together and then they gave it a new name, broken access control. Broken access control means that you have not provided proper accesses. You have given, you are using access controls, but there is a way by which we can bypass those access controls and get the access, admin access. A normal user can take admin access of the application, right? How this works, right? Let's say we are talking about IDOR. Let's talk about these vulnerabilities separately. IDOR, insecure direct object reference. Object is any entity in the web application which you are accessing, right? Let's say you went to Amazon, you opened the page of Amazon and you clicked on mobiles section, right? So that's an object, mobiles, right? Clear? Now, when we are talking about IDOR, IDOR means insecure direct object reference. That means I am just jumping from one object to another. Let's say there is one object with the name mobiles and other as accessories. So I'm jumping from one object to another and it is not being checked whether it is allowed or not. That is what that is. Insecure direct object reference. Now, how can we do that? And is it possible to perform that? Let's see. Just a second. Let me open up a machine and let me show you how it can be done, if it is possible to perform it or not. Right? Perfect. Now, let's say there is a web application which I'm accessing 75.1. Now, this is a web application, right? In this web application, if you see, this is the home page of the application, right? Uh, these are the items, the products which you can purchase from this application, right? Then sign our guestbook where you can put down your comments, whatever comments you want to put in the web application, right? Then view previous orders. If you have any made any orders in the past, those orders will be shown here, right? Then about us gives you a little description about this web application. Then there is my account. If you forgot your password, you can reset your password. If you want to log into your account or register for your new account, these are the ways. Now the thing is that if I click on what's new here, right? So we have to understand the working of the application first, then we can perform the insecure direct object reference attack, right? Check out the URL. In the URL, whatever I'm clicking, right, that is being changed. Let's say I clicked on view previous orders, right? So action becomes view previous. If I click on what's new, so action becomes what's new. What will happen if I purchase any product? So let's say I selected the very first product and I'll click on add items to cart. So action equals to cart add, right? Now what you guys have to do is you have to remember all these steps, right? Remember all the objects in between. These are all objects, right? Now I clicked on view cart. So action becomes cart view. Now let's click on place order, right? So action equals to submit payment, right? Now what I will do here, give any email and the card number, right? Then the expiry date and I'll click on place order. So once I clicked on place order, it says thank you for using Visa and it shows action equals to order, right? And your order has been placed, right? This is the normal working of the website when a normal user is using the website who is not aware about security and the attacks, right? But What I am the attacker. I know a few bits and bums about hacking. So what I will do is I'll try to bypass this payment page, right? So I selected all the products. I'll click on add items to cart. So action becomes cart add. View cart, action becomes cart view. And I'll click on place order, right? Action becomes submit payment. Now, last time I gave my credit card number and expiry date, but this time, what I will do, I remember that after submitting the payment, the action was order directly. Yes. So what I did, I changed the action to order without giving any card number or something. And it says your order has been placed, right? And all these are the items that I have purchased without giving any money. This is called insecure direct object reference, where I am referring from one object to another just by doing what? Just by changing the object name, right? Next, I told you that there was a vulnerability with the name uh, missing functional level access control. So this missing functional level access control is what you can change your accesses. You can change your privileges, right? How you can do that? Let me show you one example, one small quick example, right? Now let's say I'm trying to register for a new account, right? Let me use someone's name. Let's say I'm using Mr. Ajay's name, right? Email address ajay123 at gmail.com, and the password I'm using is this, whatever password, right? Now what will I do is, first the request this register button is sending to the target server, that request I'll capture. So I have my tool which is with the name burpsuit. Burpsuit is a proxy, as we discussed yesterday, that it will sit between your browser and the target server. So we have redirected all my requests to the burpsuit, right? So every request which will leave my browser will be captured or intercepted in burpsuit. Then from burpsuit I can forward it to the server, right? So we can see that there are multiple options, but inside these options there is an option with the name proxy, and inside proxy there is intercept, and I have put intercept on, right? Now once the intercept is on, I'll click on register, and the request which my browser was sending is captured here, right? We can see it as a post request sent to for registering. The host name, the user agent of my browser is written like Mozilla Firefox, the language which I will accept, the type of data which I'm accepting, text or HTML data, application, XHTML or XML data also, image WP, everything I'm accepting, right? Content and type, content length, the origin, referrer, cookie, everything is there. Now, here in this request, what I saw is very interesting thing. It's written role equals to you. Full name was entered by me, email was entered by me, password was entered by me, password hint was already there. I want to register. I clicked on the register button, but this role is not entered by me, right? I didn't wrote, right? So what I can do is, whenever you register on this web application, it gives you normal user access, right? Because role is always set to you. You means user, maybe. What if I change the role to A? Role equals to A, right? A means admin, right? And let's forward this request. So what I did using burpsuit, I intercepted the request, made changes to the application. Now I am logged in as Ajay inside the application, right? Now I will take help of IDOR, right? Missing functional level access control, I have changed the access control in the request. But now Action equals to admin if I write, so I am able to access the secret administration menu. And let's say I want to delete a user, I'll click on do it, and I can delete any user from this web application. I am logged in as administrator. So with the help of IDOR and missing functional level access control, I was able to exploit this vulnerability. Next, second in the list is cryptographic failures. What are cryptographic failures? Now, back in the old OWASP top 10, cryptographic failures was named as sensitive data exposure. Now, sensitive data exposure means, right, that your sensitive data is being exposed. That means if I am sending, right, uh, this cryptographic failure tells about encryption errors, lack of encryption, which can lead to the exposure of sensitive data, right? So what you are doing is, let's say I entered some data, right? There is a URL, and in the URL, I entered XYZ. Now XYZ is not the expected input from a user, but a user entered XYZ, and the reply it gave me that there is an error in your SQL syntax. Check the manual which corresponds to my SQL database or my SQL server. So just by writing anything, there is an error generated, and that error is giving you the information that in the backend, this web application is using MySQL server. That is sensitive data exposure or cryptographic failure. You have now, for mitigating that, you have to encrypt all the data at rest using secure and trusted encryption algorithm, keys and protocols, right? Encrypt all the data in transit. Do not collect and store any sensitive data, right? You are giving some information. Let's say there is an application to which you are giving a single quote, right? You added single quote in the URL, and it revealed your credit card details which it was saving. How you will feel, right? So that is sensitive data exposure. Next we have is injection. See, SQL injection is a type of injection, but what is injection? So injection is an attack against a website which exploits the vulnerability in the databases or other part of the environment, right? Now most of the types of injections, they rely on web applications inability to distinguish between user input from its code. The attacker can run malicious code in the application context and can gain access to protected areas and sensitive data, right? Like an attacker can use SQL injection, right? Attacker can do CRLF injection, right? Code injection, command injection, right? LDAP injection, multiple types of injections. But in all of these injections, we can see that there is one thing in common, that we are, whatever input we are sending, right, it is traveling in the request, and sanitization is not happening. Sanitization of whom? Of input is not happening. If there is sanitization of input happening, then there would be no vulnerability like injection, right? Then next is insecure design. Now this is a new category. It what it tells you to focus on the design and architectural flaws, right? So you have to do proper threat modeling when you are designing the application, because at the time of designing there are some things which the designer has left, and due to those things the vulnerability takes place, right? So you have to, while doing threat modeling, you have to take security into consideration in the design stage. You have to use reference architecture. You have to integrate the security from the start of the software development lifecycle, and that's why nowadays this is the era of DevSecOps. If you know development, security, and operations, all these three teams, all of them, they are just collaborating in DevSecOps, and they are building better softwares, more secure softwares. They are integrating security into every single step, every single phase of the software development lifecycle, right? Then security misconfigurations. Security misconfigurations mean incorrect access control configuration. Whenever you are configuring some devices, or you are let's say setting up a router in your organization, you have left username and password of that router as admin, so anyone can try and access. That is incorrect configuration, right? So whenever you are defining, like we did, right, missing functional level access control, right? So access control was there until unless someone changes it, right? We changed it, we got the access. So that is incorrect configuration, right? So if you are configuring something and you are not, haven't properly configured it, it allows the attacker to quickly and easily gain access to the sensitive data of the application function, right? You have to provide appropriate permissions. You have to define properly that if there is a guest user, that guest user is allowed to access what, and if the guest user is allowed to change his or her privileges or not, right? There should be no unnecessary feature activation, or the use of default accounts or default passwords should not be there, right? And there should be no detailed error messages, right? So then you can do the configuration properly, and this vulnerability won't be arising, right? Then vulnerable and outdated components. So maximum times we have seen those third party components which you are using in your organization, the application servers or web servers or operating systems or database management system, the APIs, the open source libraries, the runtime environments you are using, if they are outdated, so then the vulnerabilities arise. Like if my organization is using PHP 5.3, let's say, right? So PHP 5.3 has a vulnerability which is cross-site scripting, right? So that is outdated component. We have to update the version of PHP. We have to update the libraries in the code and the functions I have used so that the vulnerabilities does not arrive, right? So first thing, I will make it to the latest version, and then I will make changes to the code so my application is safe, right? Then identification and authentication failures. These are the vulnerabilities that arise with the functions which are related to user authentication and session management. So if you have not properly implemented the session management, it can expose the users to security credentials. It can give excessive privileges to the attackers. It can enable the users to impersonate as other identities, right? So that is identification, right? And authentication failure. Now, this identification and authentication failure can happen even if you are not having a strong password, right? You haven't enforced multi-factor authentication in your organization, right? You are not doing monitoring properly, right? Or you are not using strong user registration and credential recovery processes, right? Then these vulnerabilities arise. right? Then software and data integrity failures. So data integrity means integrity means that whenever my data is traveling during the transit, my data should not be changed. It should not be tampered with, right? Now, these integrity failures, it depends on integrity of software updates, right? Many times we have seen software updates, they arrive, right? To your Windows or any application you have installed to your device, right? Uh, how can you get to know those updates are sent by Microsoft only, not sent by someone else, right? There are some ways by which we do that, like we do SSL pinning in mobile phones, right? And mobile applications, or we sign them using like digital certificates we use, right? So if I want to make sure whatever data I am receiving or whatever update my application is receiving, that update is legit, right? Then I have to make use of digital certificates, digital signatures, right? Or some same mechanisms like digital signatures to verify that data or software has not been tampered with, right? So software and data integrity failures, they occur when any of the data is tampered by an attacker, right? And none of the component within the application is verifying the integrity, right? So you don't have to send unencrypted compiled data or unsigned data to the untrusted clients, right? So you have to implement access control, parameterization in your CI/CD pipeline, right? To protect the code integrity from the whole process of the pipeline, right? So that is software and data integrity failures. Then you have security logging and monitoring failures. Now, this logging and monitoring means that inside organizations, you are just checking logs from every single source, right? Be it your IDS, be it your IPS, be it your firewall, right? All the logs created by these security measures which you have taken are going to your SIM solution, right? That means SOC team, Security Operations Center, right? SIM solution, everyone knows security, information, and event management. Like we have Splunk or we have QRadar, right? These are the solutions. So you have to implement proper logging and monitoring that if there is any alert generated, so that alert should be noticed by you, right? So if someone is trying to attack, someone is sending lots and lots of data to your application, that means it is a DOS attack. Someone is trying to perform a DOS attack on your web application, right? So you can take actions against that person, right? And if you're not logging and monitoring properly, then attackers can take advantage of it. You won't notice anything, and attacker will be inside your network, right? Then last one is server-side request forgery. Now, when we talk about server-side request forgery, it is a very famous and very interesting vulnerability. That what I'm doing is I'm sending a request. Now that request is giving me the access of web server, right? But through that web server, I am able to access and get the information about the backend infrastructure also. I'm able to uh, redirect the web server to a place which is malicious and it is hosted by me, right? I'm I can ask the target web application to take some data. Let's say download some data abc.html file from attacker's website and download it in your website. right? I can do anything with SSRF vulnerability, right? So you being an attacker are allowed to access data on a remote resource based on an unauthenticated custom URL. And even the servers which are protected by a firewall or VPN can be vulnerable to this vulnerability, right? So this is OWASP top 10 and all the vulnerabilities in OWASP top 10. Server-side request forgery means that what I'm doing is I'm sending a request to the backend server, to the web application server, and I'm allowing the backend server to connect to the backend infrastructure. Because in an organization, there will be not only web application server, there will be multiple things, right? Right? So I'm making or I'm causing the server side application to make request to unintended location. I'm sending some request and I'm asking the web server to reach to some other place, right? Maximum times what attackers do they want to access internal services, right? I want to access internal only services, right, within the organization's infrastructure. So through this web server and by sending some requests, modified requests to this web server, I can access the backend infrastructure of the organization. Perfect. Next, access control. What do you mean by access control, guys? So access control is what? Having control to access any resource. Or I can say, yes, correct. Application of constraints on who or what is authorized to perform actions or access the resources. Right? Now, when we talk about access control, it is dependent on authentication, first thing, then session management, and access control itself. Right? Authentication means confirms that the user is same who they say they are, right? Will identify which HTTP request is made by the same user, and access control will tell whether the user is allowed to carry out the action that they are trying to perform or not, right? Now when we talk about access control vulnerabilities, so attackers can elevate or escalate their privileges, privilege escalation they can perform. Yes. So if a user can gain access to functionality that they are not permitted to access, then that is privilege escalation vulnerability, right? Now, let's say this is a website, a web application, right? Now here what we have to do is there is unprotected admin functionality, right? That means anyone can access the admin page. Now I don't know where exactly the admin page is. What I did, I searched for a place which is known as robots.txt. Whenever there is an application, maximum of applications they have robots.txt. Robots.txt will give you a list of allowed and disallowed entries for different bots or crawlers. Now, what we do, we love to crawl the unique pages, different pages of a web app, right? So if I want to crawl on a page, right? Let's say I'm using this Apple bot and I want to crawl on a web application, right? So all these are the disallowed entries for my Apple bot, right? So robots.txt is the file which is first read by crawlers, and then crawlers get to know what are the places they are not allowed to access, what are the places they are allowed to access. Yes, it can be used in any application. Maximum of applications they have robot.txt, right? So first it will be written all the disallowed entries, and if I scroll down, you will see the allowed entries for different user agents. That means different bots or crawlers. Clear? So what I did, I just checked the place robots.txt here, and when I checked robots.txt, I found the path which was already written there for administrator panel, right? So this is disallowed entry. Any crawler cannot access it, but I am a normal user, I can access it. So what I did, I tried it, I put it in the URL, and when I pressed enter, I can see I am inside the administrator panel. And if I want to delete a user, I can delete a user just like the administrator, right? This is known as access control vulnerability, right? That no one was able to find out the way, but if you found the way where exactly the administrator page is, then you are allowed to access. There is no access control provided. I hope you guys enjoyed the session. Thank you so much, guys. Have a great night. Have a great day ahead according to your time zones. Hope to see you again at InfosecTrain. And thank you so much. Take care, everyone.